We are in the middle of a revolution in cancer research. The advances over the last 20 years are coming together, and we see new connections, connecting data from genomics, cell analysis, metabolic studies, and protein profiling. Researchers see a comprehensive picture and the chain of causality. For example, an immunotherapy researcher would analyze an oncogene with genomics and determine the set of mutations. Then they would do messenger RNA profiling and proteomics and see how those oncogene mutations change the expression of other genes and the enzymes. And then with metabolomics, they see how they are affecting the tumor microenvironment. Precision oncology. Conventional chemotherapy is like trying to kill a cockroach on a window with a baseball bat. You might hit the cockroach, but you're going to break the window. Chemotherapeutic agents try to kill every cell that's dividing rapidly, and it's a race to try and kill the tumor before the side effects get too bad. One of my own sisters had a double radical mastectomy, and then chemo, and then radiation therapy. The side effects were horrific. But 26 years later, she's still alive and cancer-free. The goal of research is to get people cancer-free without having to make such horrible trade-offs. With precision oncology, we can target the tumor. We can base a treatment not only on which organ has a cancer, but also its molecular phenotype. That is revolutionary. An amazing success is CAR T, or adoptive cell therapy. The human body has a lot of mechanisms to reverse damage. For example, the immune system is able to find and kill cancer cells. Immunotherapy is enhancing that ability. With adoptive cell therapy, you're taking a person's own T cells, putting the chimeric antigen receptor on them, turning them into serial killers for cancer, and putting them back in the person. This way, the specific cancer cells are targeted, the therapy is more effective, and the side effects are less severe. At Agilent, we support researchers developing CAR T cell therapy throughout the entire process, going, as I say, from vein to vein. From selecting a person's T cells, engineering them with our genomic solutions, measuring their metabolic fitness, potency, and persistence in killing until they go back in the person. All within a couple of weeks, because the person's immune system was wiped out when the cells were taken. Another promising area is in companion diagnostics research. How do you characterize the molecular phenotype of a cancer so that you can predict what will be an effective therapy? We work with pharma companies hand in hand as they're developing a therapy. We work with them to research companion diagnostic approaches. To understand the tumor microenvironment at a detailed level, a tumor is not just a ball of normal cells that's growing faster. It's heterogeneous at the cellular level, and the tumor microenvironment is one of the reasons that it evades the immune system. The tumor cells are excreting metabolites, which are modulating the immune cell's response. A lot of incredibly bright people are using cell analysis and mass spec instruments and looking for answers why this can cause a therapy not to work and how we can make it work. To treat the person as an individual, everything must come together. Immunotherapy coupled with companion diagnostics, but also initial diagnostics. With the latest advances, we don't have to take a brute force approach every time. At Agilent, we can help researchers with an integrated portfolio of solutions, from the initial research like gene sequencing and metabolism characterization or protein analysis, all the way through to precision oncology that's guiding human therapy. Our cell analysis instruments enable a profound study of altered cell metabolism and metabolic reprogramming. Our mass spec solutions allow understanding the physiology of the cancer cell and the mechanisms that allow a cancer cell to grow so fast. All those instruments together help us understand how the tumor cells change the response of immune cells in the microenvironment. Researchers who are developing immunotherapy use our genomic solutions to analyze the mutations of oncogenes. Our companion diagnostics research team and pharma services team are developing solutions in close contact with pharma companies and researchers. Our Dako brand has decades of experience, and we understand the pathology lab, which allows us to develop diagnostic tools. It's the integrated portfolio, diagnostics and companion diagnostics, where everything works together and the development is backed up with experience and close collaboration.